Good evening, students. Welcome to APJ Academy. So, hope you all are doing well, and I hope your studies are going well as well. Okay. So, dear students, today, as you have seen in the thumbnail, we are going to discuss about a new topic from states of matter, that is regarding the Vanderwaals equation as well as Dalton's law. Okay, Dalton's law regarding the partial pressure, and these are the topics which we are going to handle today. Okay, so before going into the topic, let's discuss some facts regarding our academy. So this is the full year course which we are providing for you, and in that course you can see that we provide all the required materials for you, the test series and doubt solving. Likewise, we also provide the in-depth lessons, that means with proper conceptual clarity, and after every lesson you will be given the assignments in order to test your knowledge, your concepts and your grasping power. Everything will be tested with that assignments, so that you will be kept on a clear track to crack NEET or as well as JEE exams. Okay, so that's all about our full year course. You can, if you want to know more, you can contact us, and we are providing this course with an enormous discount, and you only required to pay a rupees of just 490. Okay, just you have to pay 490 per month, right? Now if you are watching this channel for the first time, I would like to tell that you please subscribe to the channel, because it will surely add value to your preparation, because we are giving quality content for free. We are regularly uploading classes, we are regularly giving you free classes, and that too live, so that you can be part of this revolution and you can earn more, right? Earn more knowledge, and you can add value to your preparation. So you can subscribe to this channel, as well as please share the channel with your friends, those who are seriously preparing for NEET as well as JEE. We have two channels, that is one for JEE and the other is for NEET. Okay, right. Now, and that's me, and this is all about me. You can read what I am, who I am, okay, what are my credentials, right? Yes, Pro Tej, good evening. It's been a long time no see, right? How's your preparation going, Pro Tej? So, coming to the topic here, dear students, what you have to understand from this topic is that first of all, I have to tell you, this Dalton's law of partial pressure is not a topic that you can concise in states of matter, but this topic you can see where you can see the application. Oh, you have given the exam, very good. How was it, Tej? So you can see the application of this law in the chapter solutions of second year. Sorry to say, but it was tough. Why you should be sorry to say that it was tough? Tej, that happens. This is a competitive exam. Okay, so you even if it is tough, what you have to do, if NEET exam or cracking the NEET exam or to become an MBBS doctor is your dream, then failures should not keep you step back. Okay, failures should motivate you. Learn from the mistakes that you have made in the previous years, understand what went wrong, clarify that, make changes to what was lacking in your preparation, and prepare for the next exam. That means if you like to take a drop for a year, take a drop. Don't worry about taking a drop, and do your best that year, understanding what all mistakes you have made in the previous year, and the next year will be your year if you consistently if you make progress in your preparations. Okay, so that's how you have to go. Okay, we know that 18 lakhs of students have given this exam, and we know only 50 to 60,000 students are going to get the government seats, right? So the competition is very high. So we have to understand what is the requirement of the exam. Normally students make a big mistake that they keep on studying more and more concepts without understanding what kind of exam they are appearing to. Actually, this exam, even if you have studied 100% of concept, that will not give you rank. What you have to do, you have to know the practical application of your knowledge by practicing more and more questions and doing those questions in lesser time. So your reading skills matters. You have to improve your reading skill. You have to improve your reading speed, your catching power. You have to improve that, one thing. Second thing, you have to improve your concentration skill. See, you know that in between the NEET exams, the teachers or the invigilators will come and ask you to sign there, put your thumb impression here. They'll keep on coming to you and start disturbing you. But you should be that particular person whose concentration cannot be breakable. So you have to practice concentration, and 1 year you practice concentration by doing proper meditation, so that it will help you. Okay, it will help you in the upcoming exams. That's the second thing, concentration, very important thing. Third, your mathematical ability, your problem solving skill. You should solve the problems in 1 minute. So what you have to do, you have to practice keeping in mind, keep a timetable, keep a timepiece with you, keep a stopwatch with you, start your stopwatch, try doing your problem, and let's see how much time you take. And if it is taking 3 minutes, let's say it takes 5 or 10 minutes at first, but being conscious about that much time you are taking for the solving an answer, the next time inside your mind you will have that feeling, I have to do it much faster. So day by day you keep progressing. Okay, so that's another area you have to keep in mind. And the fourth point you have to keep in mind is that proper revision. Revision is the key, because for NEET exam you should study 98 chapters, physics, chemistry and biology. So all these 98 chapters, its concepts, its important points, everything should be here in your mind. For that 3 hours and 20 minutes on that particular day, it should be here. So how you are going to remember all this? It is hard, but it's easy. How to do it? Scientifically revise. Scientifically keep revising, so that it will help you remember all the facts and figures and important concepts that you have studied for the past 1 year. Okay, so this is what you have to do. Yes, Sheikh Hunzi, hi and good evening. Are you from Pakistan? So last day while I was taking the session, there was a student who came from Pakistan. We had a good time. Okay, right. So that's all I right now. These are the guidelines I want to give to you, Protej. So remember these points, follow these points, and the most important thing is that if you are taking a drop, eventually you will start to get demotivated. Your confidence will start to decrease. At that time, always remember why you have started. Why you have started. Remember about your parents. Remember or visualize your future. Okay, so these are the points I wanted to give you, and this is what I want to tell you in the beginning of your preparations. So hope the next year is yours. So keep fighting, never ever give up on your dreams. Okay, yes. Sheikh Hunzi is saying, no, I am from India, Very good. Even if you are from Pakistan also, I'll say that. Very good. Okay. Right. So, coming back to the topic, today we are going to discuss about the Dalton's law of partial pressures. So, as I have told you, Dalton's law of partial pressure is very important. Not only from this chapter, from solutions also you can see the application of Dalton's law of partial pressure. See, there is a topic regarding the vapor pressure. We know that there is a colligative property called as a relative lowering of vapor pressure. There, Raoult's law is the law that guides us to find out the vapor pressure of the solution. So, repeatedly they have been asking in IIT JEE mains exam, JEE mains, that they repeatedly asking the relation between the Dalton's law and Raoult's law. They connect the Dalton's law and Raoult's law and they will ask a numerical question. That means they ask you to find out the pressure or the mole fraction of the gaseous mixture present in that container. So what students who doesn't know that connection, they calculate the mole fraction of the solution. Actually, how we calculate the vapor pressure, we calculate the vapor pressure of the solution with the formula that mole fraction of the solution or the solvent or solute into the vapor pressure of the pure solvent. That's how we calculate or we measure the vapor pressure of the solution. Okay, so they get confused on that, and without knowing that connections between Raoult's law and Dalton's law, they make a big mistake. And this year, even this year also, there was a question that asked with the relationship between the Dalton's law and Raoult's law. So while taking solutions, I'll bring that up. But right now we are going to master what Dalton's law of partial pressure all about. Okay. So what's the point? What's the point? Let's start with the basics. So what Dalton says that at constant temperature, the total pressure exerted by a mixture of non-reactive gases, that's the point you have to remember. So what Dalton is saying that if you consider a container, a closed container, where this closed container contains three different gases, let's say A, B and C. The most important thing that you have to keep in mind that these three gases are non-reactive gases. Why he have told that it is non-reactive? Because if these gases are reactive in nature, that means they react by colliding. You know, in chemical kinetics you might have studied that when the molecules collide each other, they break their existing bonds and start to form new bonds. That's what chemical kinetics says. So as per the frequency of collision increases, the rate of reaction increases. So I am not going into that point. I wanted to tell you that if the gases are non-reactive, even if they collide, there is no breaking of existing bond or there is no formation of new bond. That means there is no chemical reaction. So if there is no chemical reaction, that means there will not be any sort of energy releasing process. Okay, no energy will be released. We know that when new bonds are formed, energy will be released. Okay, so here the energy is conserved in the system, right? So it should be non-reactive gases. Then only Dalton's law will be applicable. If you are taking a container with the reactive gases, there may be chances that the two gases react together and form a product which is liquid in nature or which becomes a precipitate. Okay, so these all possibilities are there. So here, for application of Dalton's law, the very first thing you have to keep in mind that the mixture of gases should be non-reactive. They should not be reacting with each other. So what he is saying is that the total pressure exerted by the mixture of gas. So can you say what will be the total pressure of this container? We know that there are three types of gases, and these three types of gases are colliding with the walls of the container and they are exerting pressure. So Dalton is saying that the total pressure in that container, the total pressure in that container is equal to the partial pressure of individual gas. That means partial pressure means sometimes the students think that partial pressure means it is half of the total pressure. No, partial pressure only means the individual pressure of the gas. How much pressure is exerted by A, that particular value or that particular pressure is called as partial pressure of A. Okay, so we only uses two terms for pressure. One is partial pressure, the other is total pressure. Partial pressure means individual pressure. Okay, so PT is equal to PA plus PB. PT means total pressure. Total pressure is equal to sum of the individual pressure. If I have taken 4 gases, then total pressure will be equal to PA plus PB plus PC. Like that it goes. Okay, hope that is clear. So if P total is the total pressure of the mixture of non-reacting gases at temperature T and volume V, and P1, P2, P3 represent the partial pressures of the gases, then P total will be equal to P1 plus P2 plus P3 plus etc. That's the point which I have explained just now. So hope that concept is clear for you. If you are taking a container in which there are mixture of gases present, and the thing is these gases should be inert with respect to each other, that means they should not react with each other. Yes, Sheikh Unzi, that's correct. And if that is P total, so the total pressure inside that container will be equal to the sum of the individual pressure exerted by the gases. So we have 3 gases, then the total pressure will be PA plus PB plus PC. Okay, Sheikh, are you a student? Are you a student of APJ Academy? Okay, now we are moving to the next topic that is related to this one itself. So, partial pressure in terms of mole fractions. So, this fact also comes from the Daltons law. Okay, so suppose at temperature T, 3 gases are enclosed in the volume V, exert partial pressures P1, P2 and P3. That means, let's take this example. I have a container where there are 3 gases, gas A, gas B and gas C. We know that gas B will hit the container exerting pressure. Okay, similarly gas A also will hit the container and exerts the pressure. Similarly gas C also hit the walls of the container and exerts pressure. Okay, you are just a NEET aspirant. Okay, very good. Right. So, are you a repeater, Sheikh, or are you a student of plus 11 standard or 12 standard, or are you a repeater? So, we have 3 gases in that container. So, I wanted to calculate the individual pressure, or we can call it as a partial pressure exerted by A. So, that is equal to, we know that in the last class we have studied that PV is equal to nRT. PV is equal to nRT, that means P is equal to nRT by V. This is the formula to find out the partial pressure of a gas molecule. So, PA is equal to number of moles of A into R, that is the ideal gas constant, into temperature divided by the total volume. Okay. So, you have plus 2, plus 12. Okay, right, very good. So, where are you from, or in which school are you studying? Partial pressure of B is equal to number of moles of B into R into T divided by total volume. Similarly, for partial pressure of C equal to number of moles of C RT by V. So, this is simple equation. If you know the ideal gas equation, you can simply find out. So, you are from, no, Sheikh Unzi, I am from India. I born and brought up in India only. Okay. From Kerala, South India. So, 3 partial pressures, PA equal to NART by V, PB is equal to NBRT by V, and PC is equal to NCRT by V, where Na, NB and NC are the number of moles of gases. Okay, right. So is that clear, students? Till here, is it clear for you? Now let's consider this. I'll do the same thing on the right hand side. So as we have studied from Dalton's law that total pressure is equal to PA plus PB plus PC. So I'm just substituting the values here. That is, it is NA RT by V plus NB RT by V and plus NC RT by V. Okay. So we know that from here, let's take RT by V common. Let's take RT by V common. So it becomes NA plus NB plus NC into RT by V. Okay. So for total pressure, we will just write it as P total. Okay. So now I am dividing, this is the equation for the total pressure. Let's take the pressure of A. Pressure of A, we know that it is NART by V. So what I am going to do is that let's take this as equation 1 and this as equation 2. I am just dividing 2 by 1. What I am going to get is 2 by 1. I am going to get NA into RT by V, that is 2, equation number 2, divided by equation number 1, that is PA by PT. PA by PT is equal to NA into RT by V divided by NA plus NB plus NC into RT by V. So you can cancel RT by V, and what you are getting is, I'll write it in the next page so that you can clearly see it. That is PA by PT is equal to NA divided by NA plus NB plus NC. This is what we finally got, right? So what is this? This is mole fraction. This is mole fraction. So PA by PT is equal to mole fraction of A. And don't ask me what is mole fraction. We have discussed what is mole fraction in detail from the chapter Some Basic Concepts of Chemistry. Okay, some basic concepts we have discussed in detail about. In the mole concept also, the concentration terms, we have discussed what is mole fraction. So from here we can calculate the partial pressure of A is equal to mole fraction of A into total pressure. This is a very important relation. I will give you a theoretical explanation on what does this mean. See students, see, sorry for that. See, we have taken the container, and in the container we know that there are 3 different gases present, and we know that these 3 gases are not non-reactive gases. They do not react each other. So if these molecules go and hit the walls of the container, what happens is that we will get a total pressure. And I wanted to calculate the individual pressure of A, B or C. We know the total pressure. If I place a barometer here, I'll get the total pressure reading here. From here, I'll get the total pressure reading. So it is easy to find out the total pressure, but it is difficult to find out the individual pressure. So this relation PA equal to XA into PT, or mole fraction of A into PT, will give us the individual pressure or the partial pressure exerted by each gases. So I know by placing a barometer, by measuring the total pressure, we get the value of total pressure. What I have to do in order to find out the partial pressure of A? You only have to do find out the mole fraction of A, then just multiply it with total pressure, that's all. So mole fraction means what? Mole fraction means the fraction of molecules of A present in the total container. So the fraction of molecules of A present in the total container into total pressure will give you the partial pressure of A. Similarly, if you want to find out the partial pressure of B, what do you have to do? Just find out the mole fraction of B and multiply it with total pressure P. If you want to find out the partial pressure of C, just find out the mole fraction of C and multiply with the total pressure. So hope this concept is clear for you guys. So this is all about the Dalton's law of partial pressure. We have explained the concept of Dalton's law first. Then we made a relationship between the total pressure and the partial pressure with the mole fraction, right? So I hope in total you got the clear picture regarding the Dalton's partial pressure concept. If this is clear, please let me know in the comment section so that we can do 2 or 3 problems regarding this. Yes. So if you know the individual mole fractions of each gases, just multiply it with the total pressure so that you will get the partial pressure of each gases. Yes. Okay. I also want to give you a brief idea on aqueous tension. See, there are 2 different types of gases. One is dry gas and the other is wet gas. One is dry gas, other is moist gas. Okay, so say that if I am taking a gas inside a container, this is simply a dry gas, nothing much to discuss about that, it's simply a dry gas. If in a container I am taking water, okay, and above this I am filling it with a gas, what happens? Along with due to the presence of gas, we know that gas have the high thermal energy, so the temperature inside the container will be on the higher side. It will be greater than the room temperature. So what happens is that the water start to evaporate. So in this gas we get 2 gases. One is the gas that we have filled, along with that there will be water vapor. Okay, so whenever you are taking gas over water, what happens is that the total pressure exerted there, the total pressure will be equal to the pressure exerted by the gas and the pressure exerted by water vapor. And this pressure exerted by water vapor is called as aqueous tension. It is called as aqueous tension. What does that mean? Aqueous means, aqua means water and tension means the force exerted by the water vapor. So moist gas, dry gas is simply a gas where there is only the molecules of gas itself. Okay, when I am discussing about moist gas, what does that mean? Moist gas contains 2 different molecules of gas. One molecule will be that of the gas and the other molecule will be the molecules of water or H2O molecules. Is a concept of moist gas and dry gas clear for you, students? So here you might not be seeing because I am just this part I am covering with my head, so I will write it again. So here the pressure of the gas, total pressure P total will be equal to pressure of gas plus pressure of water vapor. That is, let me write it as H2O gas. And this pressure of water vapor is called as the aqueous tension. Okay, so this process or this gas you can call it as moist gas. So moist gas is only means that when you have taken the gas with water, okay, what happens? The water start to evaporate and in that gas molecules, along with the gas molecules, water molecules in gaseous form will also be present. So we can call that gas as moist gas and the pressure exerted by the water vapor is called as the aqueous tension. So whenever you are dealing with the moist gas, remember there will be 2 pressure. one is the pressure exerted by the gas molecules itself, and the other is the pressure exerted by the water molecules in gaseous form. Okay, so hope that concept is clear for you. Now we will move on to solve a problem, and this one we have already discussed, that is P2 equal to mole fraction into total pressure, P3 equal to mole fraction of 3 into total pressure. So we can generalize that partial pressure of a gas is equal to mole fraction of a gas into the total pressure, right? So this is the question. You can try solving this question. So a neon dioxygen mixture contains 70.6 gram of O2 and 167.5 gram of neon. That means in a container we have a mixture of gas, that means it consists of neon and oxygen gas. Okay, so they have given the weight of both the gases. Now if the pressure of the mixture of gas in the cylinder is 25 bar, that means they have given the total pressure that is equal to 25 bar. Now see what you have to find out. What is the partial pressure of O2 and Ne in the mixture? So now the equation is simple. You have to find the partial pressure of O2. So partial pressure of O2 is equal to mole fraction of O2 into total pressure, that is mole fraction of O2 into 25 bar. Okay, now you have to find out the partial pressure of neon, that is equal to mole fraction of neon into total pressure. Okay, that is mole fraction of neon into 25. Yeah, bro, I'm a bit sick. I have cold. Okay. So here for finding out the mole fraction, we know that mole fraction of oxygen is equal to number of moles of oxygen by total moles. What are the total moles? Total moles means number of moles of oxygen plus number of moles of neon. Similarly, to find out the mole fraction of neon, number of moles of neon divided by total moles, that means number of moles of neon plus number of moles of oxygen. So here we have to find out the number of moles. So for finding out the number of moles, they have already given us a weight in grams of both the gases. So let's calculate the number of moles. We know that number of moles equal to weight by molar mass. So let's find out the number of moles of O2. Let's take in the next page, new page. That is number of moles of O2 is equal to weight of oxygen is 70.6. Okay, 70.6 divided by molar mass of oxygen. We know that it is 32, right? So 70.6 divided by 32, it will be nearly equal to 2.21 moles. So in order to not to waste time, I have already calculated this value and kept the answer. Okay, you can, if you want, you can try it yourself. Now the number of moles of neon is equal to, what is the weight of neon? That is 167.5. and what is the molar mass of neon? That is 20 gram per mole. So we will get a value of 8.375 moles. Here we got the number of moles of oxygen and neon. Now we have to find out the mole fraction of O2, that is 2.21 divided by 2.21 plus 8.375. So we get a value 0.21 is the mole fraction of oxygen. Now mole fraction of neon is equal to 8.375 divided by 2.21 plus 8.375. Add the value, divide it. So you will be getting a value nearly equal to 0.79. Or if you do not want to do this, you can do another formula, that is mole fraction of neon will be equal to, or mole fraction of neon plus O2 equal to 1. So mole fraction of neon equal to 1 minus mole fraction of O2. So that will be the better option. Okay, you can do it like that. So mole fraction of neon equal to 1 minus mole fraction of O2 is 0.21. So you will get a value of 0.79. Okay. Now we got the mole fractions of neon as well as mole fraction of oxygen. Now what's the next step? We can find out the partial pressure of O2 that is equal to mole fraction of O2 into P total. So what is mole fraction of O2? Mole fraction of O2 is 0.21. So 0.21 into 25 bar. Okay, 0.21 into 25 bar, that is equal to 5.25 bar is the answer. Now mole fraction of neon is equal to partial pressure of neon is equal to mole fraction of neon into total pressure. What is the value of partial pressure? What is the value of mole fraction of neon? That is 0.79. So 0.79 into 25, that is equal to 19.75 bar. So these are the partial pressures of oxygen and neon that is present in the mixture of gases. Is it clear, students? Is it clear? Yes. So if you understand the concepts properly, that's the very first step. Then you have to do more and more problems so that you will get an idea how to apply these concepts in the analytical aspects. Okay, where if you are asked the concepts in the numerical form, so you should have to develop a particular analytical skill so that you can analyze these concepts, and at the same time you should know how to apply these concepts in a numerical problems. Okay, Kirtana, how are you? Kirtana, how are you doing? Have you given your NEET exam this year? Or are you a student of 11th standard or 12th standard? Meanwhile, let's do another problem. So this is again a very interesting problem, that is, a certain quantity of gas occupies a volume of 0.8 liter collected over water. See, they have collected the gas over water. So this is the case where aqueous tension will be there. That means yes sir, I am a Malayali. Okay, fine. So here we have water. Okay, so and here we have filled a gas in this container, and this gas occupies a volume of 0.8 liter. So the volume occupied by the gas is 0.8 liter. How was your exam, Kirtana? I mean the NEET exam. Was it easy? And a pressure of 0.92 bar, and the same. Now let's read the question. So a certain quantity of gas occupies a volume of 0.8 liter collected over water at temperature 300 Kelvin and a pressure 0.92 bar. The same gas occupies a volume of 0.02 liter at STP in dry conditions. So you might got the point that in dry conditions it occupies only 0.08 liter volume. Okay. But in the moist condition, it is occupying a volume of 0.8. That means the rest part of that will be water vapor, right? The rest part will be water vapor. So 0.08 liter is the volume of the dry gas, and 0.8 liter is the volume of the moist gas. So in moist gas, we know that there are two gases. One is the dry gas, the other is the water vapor. So what will be the volume of the water vapor? Volume of water vapor will be equal to 0.8 minus 0.08, that will be equal to 0.72 liter. So 0.72 liter will be the volume of the water vapor. Okay, whatever. Calculate the aqueous tension. You have to calculate the pressure exerted by the water vapor is what we have to find. Right. So let the aqueous tension let the aqueous tension at 300 Kelvin be P bars. So I am assuming that the aqueous tension or the pressure exerted by the water vapor is equal to P. Okay. So what will be the pressure of the dry gas? The pressure of dry gas will be equal to 0.92 minus P bar. This will be the pressure of the dry gas. The total pressure is 0.92. That means in that total pressure we have two pressures, that is one pressure is exerted by the dry gas and the other pressure is exerted by water vapor, or you can call it as aqueous tension. So I am taking the aqueous tension as P. So the pressure of the dry gas will be equal to 0.92 minus P. Okay. Now in the first condition we have, in the dry in the moist condition we have volume equal to 0.8 liter. And in the corresponding to that we have a temperature of 300 Kelvin. And in the dry condition we have a volume of 0.08 liter with a temperature of 273. Because it has been told that at STP, we know that at STP the temperature will be equal to 273.15 Kelvin. Okay. So knowing these values, what you have to do? We are going to use the combined gas law equation where P1 V1 by T1 is equal to P2 V2 by T2 in order to find out what is the pressure of P1. Okay. So P1 is equal to P2 V2, here it is T2, into T1 divided by T2. So what is P1 actually? P1 is the pressure of dry gas, that is equal to 0.92 minus P. So just apply here 0.92 minus P equal to, what is P2? P2 is the at standard temperature pressure. It has been mentioned that at standard temperature pressure means the pressure P2 equal to 1 bar actually. Okay. So now apply that P2 equal to 1, V2 equal to 0.08 and T1 is equal to 300 divided by T2 equal to 273.15. Okay. So have we missed something? Yes, we have missed V1 here. There is V1. So what is V1? V1 is equal to 0.8 liters. So calculating this, we get a value 0.109. So 0.92 minus P equal to 0.109, that is P equal to 0.92 minus 0.109, that is equal to 0.811 bar. 0.811 bar. So we got the value of aqueous tension, that is equal to 0.811 bar. This is a very, very important as well as very good question. Okay, if you have understand all the steps which I have done here, then I can guarantee you have got the question properly. Okay, please let me know, students, if this is clear for you. If not, I will repeat this question once again. Please let me know. I am waiting for your comment. Just let me know whether this is clear for you. If not, I'll explain once more. So prior to this question, I gave you a clear-cut picture on what is aqueous tension, what happens when a dry gas is taken over water. So I have given that picture so that you can solve this kind of questions, and these type of questions are average level questions. This question is not tough one, but it's an average level question. Okay, so in NEET we have three categories of question. One is easy, which is direct, and one is average, that means they will have two concepts together in one question. So here there is Dalton's law of partial pressure is there, and the aqueous tension concept is there. So I am waiting for your comment. Please let me know if this is clear for you. If not, I'll explain once more. Yes. Shall we move on to the next? Where is Protej? Where is Sheikh Unzi? Kirtana? Where are you guys? Okay, hope it is clear for you. If not, you can just please explain once more. Okay, Kirtana. Let's listen here. Here you can see that let's read the question carefully. Okay, read the question very carefully. That is, a certain quantity of gas occupies a volume of 0.8 liter collected over water at 300 Kelvin. I'll explain this sentence. What they are telling is that there is a container which is having water in it, and in that container the rest of the space have been filled with gas. So here there is gas, and the volume occupied by this gas is called as a moist gas. Why I call it a moist gas? Because in that gas it consists of, since the container consists of water, there will be vapors, water vapors. So it was initially dry gas when we were putting that into the container. Gradually what happens to the water starts to evaporate. So along with the dry gas, we know that there will be water vapor. So the volume of moist gas is equal to how much? Is equal to 0.8 liter is what given in the question. Is that point clear for you? Is that point clear for you? So here in this we have two gases. One is the dry gas, other is the water vapor. Other is the water vapor. These are the two gases present in that region. Okay. So we have volume of moist gas. We call the moist gas. Hope you have seen that extension part which I have explained in this today. I have explained that. Hope you have seen that. Okay. So if you have not seen, then you have to see that first, then only you have to do this problem. If you have not seen that, this will be confusing for you. So I am explaining it again. If you have taken the gas inside a container where there is liquid, what happens? Along with the gas, the water vapor will also be present. So now we can take it as a moist gas. So the moist gas, the volume is 0.8 liters. That is what the first sentence is telling us. And the temperature is 300 Kelvin. So temperature is 300 Kelvin. Okay, that also we understood. Now what they are telling in the next one, and a pressure also 0.92 bar. So the pressure is 0.92 bar. See Kirtana, here why they are given 0.92? This 0.92 is not the pressure of this gas. It is the pressure of the gas with the water vapor. So let's take the pressure of water vapor equal to P. Let's take the pressure of water vapor equal to P. So what will be the total pressure? That is the pressure of gas plus P is equal to 0.92 bar. Right? The pressure of gas is given as 0.92, and that pressure of gas means the pressure of the dry gas and the pressure of water vapor. That too you have to consider. That is the twist in the question. That is what they have not given you direct. This is what the conceptual learning means. If the gas is taken above water level, then obviously there will be water vapors. So the total pressure, that is 9.92 bar, means there will be the pressure of gas and pressure of water vapor. Or what do you call the pressure of water vapor? We call the pressure of water vapor as extension. So I am taking the extension P equal to 0.92 minus pressure of gas. Okay, let it be there. Let it be there like this. Is this first sentence, first part of the question is this much? Is it clear for you? Is it clear for you? Actually, we have to find out the extension. Actually, we have to find out the extension. That is P is what we have to find out. What is P? P is extension. So this is all about the first part. Okay. Now let's see what is there in the second part. In the second part, you can see that the same gas occupies a volume of 0.02 liter. So that's the another condition, and let's read it fully. At STP in dry conditions. So what they are telling us, at STP, that is at standard temperature and pressure condition, the gas we have taken in dry condition occupies a volume of 0.08 liter. What does that mean? Now there is no water vapor. Now there is no water vapor in the gas. It is the dry gas alone. So that is the second condition. So for second condition, I am going to take pressure is equal to 1 bar. Why I have taken 1 bar? Because in the question it has told that the dry gas has been taken at standard temperature pressure. So standard pressure is 1 bar. What is standard temperature? Standard temperature is equal to 273.15 Kelvin. That is the standard temperature. Now what is the volume of dry gas? Volume of dry gas equal to 0.08 liter. So we got P2, T2 and V2 or V dry gas. We have P1, V1 and T1. Okay. So these three or these six values we know. So we are going to apply this formula, that is P1 V1 by T1 is equal to P2 V2 by T2. Okay. Now what we have to find out? We have to find out P1, right? We have to find out P1. What is P1 actually? P1 is 0.92 minus pressure of gas. Okay. P1 is 0.92 minus sorry. That is where is the rubber? What is P1 actually? P1 is the pressure of, this is water vapor, and P1 is the pressure of dry gas. Okay. P1 is the pressure of dry gas. Yes. P1 is the pressure of dry gas, that is 0.92 is the total pressure. We have to subtract it with the aqueous tension, that is P. Okay. We have written here pressure of water vapor is equal to P, and we know that P1 plus P is equal to 0.92. That means what is P1? P1 is equal to 0.92 minus P. Okay, you might not see that, right? So let me write it here. We know that here there is two gases, that is one is the dry gas, the other is water vapor. So I am taking P1. P1 is the pressure of dry gas, Okay. So P1 plus P is equal to 0.92. So what is P1? P1 is equal to, it is not P2, P1 is equal to 0.92 minus P. So we are going to substitute that value here. P1 is equal to 0.92 minus P into V1. We know that it is 0.8 divided by T1, 300 Kelvin, equal to P2. What is P2? 1 bar. What is V2? 0.08 divided by what is T2? 273.15. So from here I can write 0.92 minus P is equal to 1 into 0.08 into 300 divided by 0.8 into 273.15. Is that clear? Is that clear? Yes. Is equal to 0.109. So P, I'll take the P to RHS. So P will be equal to 0.92 minus 0.109. That is equal to 0.811 bar. Yes, Kirtana, is it clear? Is it clear for you? Right? So it's a very good question. It's a very good question. This question can be asked if they decide, if the NTA decides to ask an average question from states of matter. This can be the question that can be asked. Okay. Now let's do the last problem from this segment. Okay, so let's read the question properly. At sea level, the composition of dry air is approximately N2 equal to 75.5%, O2 equal to 23.2%, and argon equal to 1.3% by mass. If the total pressure at sea level is 1 bar, what is the partial pressure of each component? So here this is a very easy question, right? We have given the total pressure is equal to 1 bar. Okay, fine. What you have to find out the partial pressure of each component, that is partial pressure of N2 is equal to mole fraction of N2 into total pressure. Partial pressure of O2 is equal to mole fraction of O2 into total pressure. Partial pressure of argon is equal to mole fraction of argon into total pressure. This is what we have to calculate, right? So for calculating that, first we have to find out the number of moles. So for finding out the number of moles, we have to get the weight in grams. Okay, so here they have given that this percentage corresponds to the mass. So let's assume that there is 100 gram of gaseous mixture. 100 gram of gaseous mixture. So for 100 gram of gaseous mixture, how many grams of N2 will be there? 75.5 gram N2 will be there. So weight of N2 equal to 75.5 gram. Weight of O2 is equal to 23.2 gram and weight of argon is equal to 1.3 gram. Okay, so that is how you have to convert the percentage into mass. Okay, so assuming that the total gaseous mixture consists of 100 gram, then you can directly write weight of N2 equal to 75.5, weight of oxygen equal to 23.2 and weight of argon is equal to 1.3. Now we can calculate the number of moles. That number of moles of N2 equal to weight of N2 divided by molar mass of N2, that is 28, right? So 75.5 divided by 28 is equal to 2.7. That is the number of moles of N2. Now number of moles of O2 is equal to 23.2, that is the weight divided by the molar mass, that is equal to 32. So that will be equal to 0.725. Now the number of moles of argon is equal to 1.3 divided by weight of argon, that is molar mass of argon, that is equal to 40, equal to 0.0325. Okay, so we got all the number of moles of these gases. Now what you have to do? You have to find out the partial pressure. So before that we have to find out the mole fraction, right? So for mole fraction of N2 equal to number of moles of N2, that is 2.7 divided by total moles. What are the total moles? 2.7 plus 0.725 plus 0.0325. Okay, and this total value is equal to 3.45. So mole fraction of N2 equal to 2.7 by 3.45. Similarly, mole fraction of O2 is equal to number of moles of O2, that is 0.725 divided by 3.45, and mole fraction of argon, that is equal to 0.0325 divided by 3.45. Okay, what are the values of mole fraction of N2? That is equal to 0.781 and mole fraction of O2 is equal to 0.209 and mole fraction of argon is equal to 9.39 into 10 raised to minus 3. These are the three values that you are going to get for the mole fractions of N2, O2 and argon. Now what you have to find out? You have to find out the partial pressure N2, that is mole fraction of N2 into total pressure, that is 1 gram or 1 bar already given in the question. So 0.781 into 1 bar, that is equal to 0.781 bar is the answer. Now partial pressure of O2 is equal to mole fraction of O2 into total pressure, that is equal to 0.209 into total pressure is 1 bar, that is equal to 0.209 bar. Now the last one is partial pressure of argon is equal to mole fraction of argon into total pressure, that is equal to 9.39 into 10 raised to minus 3 into 1 bar, that is equal to 9.39 into 10 raised to minus 3 bar. So this is the answer for the question. We have discussed about the Dalton's law, and we have discussed about the aqueous tension. When the dry gas, when you are collecting the dry gas over the water, what happens, that gas will become moist, and the pressure will be, the total pressure will be equal to the gas, the pressure exerted by the dry gas along with the aqueous tension. Aqueous tension means the pressure exerted by the water vapor. Is this clear, students? Is this clear? Yes. So this is all about today's session. Hope these were useful for you, right? So constantly study, learn, keep on practicing. This is what will help you to score good marks in the NEET examination. So hope you will follow the guidance, right? Kirtana, thank you for watching. Have a good dinner and good night. Okay. So that's all, students. Have a nice day.